Good morning and welcome to the Clovis Brief. I'm your host, and today is Saturday, May 16th, 2026. Great to have you with me for our weekend edition. Let me tell you about the weather situation here in northern Illinois. Right now, it's actually quite pleasant. We're sitting at about 69 degrees, though it feels more like 72, with mainly clear skies. The wind is coming through at about 7 miles per hour, so it's pretty calm. But don't let that fool you, because we've got some wet weather moving in. Today, Saturday, we're looking at a high of 81 and a low around 59, with rain expected to bring about 0.17 inches of precipitation. Sunday continues the wet trend with a high of 72, low of 63, and nearly 0.2 inches of rain. Monday is where things get interesting. We're expecting thunderstorms with the high reaching 79, low of 66, and over a third of an inch of rain. That's the heaviest precipitation day of the forecast period. Tuesday stays wet with about 0.23 inches expected, high of 74, dropping down to 54 overnight. Then Wednesday brings a significant cool down. We're only hitting 53 degrees for the high with a low of 43 and overcast skies. So if you've got outdoor plans this weekend, maybe keep an eye on the radar. Coming up on today's show, we've got quite a lot to cover. We'll dive into some fascinating discussions happening in the tech community, including a significant conversation about AI's impact on workplace culture and some really interesting developments in open-source world models. We've got several critical security vulnerabilities to walk through, including some Microsoft Exchange and Cisco SD-WAN issues that need your attention. And we'll wrap up with our PCNSE study segment, where we're going to really dig deep into packet processing order. This is fundamental stuff if you're working with Palo Alto firewalls or preparing for that certification. Let's get started. Let's jump into our tech news segment. There's quite a bit of interesting discussion happening across the tech communities today, so let me walk you through the highlights. Starting with what's generating the most discussion over on Hacker News, a post from Mitchell Hashimoto that has absolutely blown up with over 1,578 points and more than 800 comments. Mitchell's statement is pretty direct. I believe there are entire companies right now under AI psychosis. Now, for context, Mitchell is the founder of HashiCorp, so he's not just some random observer, he's someone who's built significant infrastructure companies and has a deep understanding of how technology decisions ripple through organizations. The core argument here is that some companies are making fundamental business and product decisions based on AI hype rather than sound engineering and business principles. It's what he's calling AI psychosis, this state where the potential of AI becomes so all-consuming that it distorts decision-making. The discussion thread is fascinating because you've got people on both sides. Some folks are sharing stories of their companies pivoting entire roadmaps to incorporate AI features that customers didn't ask for and don't need. Others are arguing that this is just the normal cycle of technology adoption, similar to what we saw with mobile-first strategies or cloud migrations. What makes this particularly relevant right now is that we're seeing this play out in real time, with companies burning through significant capital on AI initiatives, while fundamental business metrics might not be supporting those investments. It's a conversation worth following because it touches on broader questions about how we evaluate and adopt transformative technologies. Moving to something more technical, there's a really impressive project getting attention from NVIDIA Labs called SCNAWM, which is a 2.6 billion parameter open-source world model capable of generating 1-minute 720p video. This is being discussed extensively on Hacker News with 94 points and 40 comments. Now, world models are a fascinating area of AI research. Essentially, these are systems that can predict what happens next in a video sequence by building an internal representation of how the world works. What makes SCNAWM notable is the combination of output quality and the fact that it's open source. At 2.6 billion parameters, this is actually relatively efficient compared to some of the massive models we've been seeing. The ability to generate minute-long, 720p video is significant because temporal consistency over that duration is genuinely hard. Most video generation models struggle to maintain coherent physics, lighting, and object permanence over extended sequences. The implications here go beyond just making cool videos. World models are fundamental to robotics, autonomous systems, and simulation environments. If you can accurately predict how the world will respond to actions, you can plan better. I'll link to the project page in the show notes if you want to dive into the technical details. Over on LobStarS, there's a really interesting meta-discussion happening about LLM-generated submissions that's garnered 343 points. The community is debating whether submissions that are primarily or entirely generated by large language models should be allowed. This touches on something fundamental about what these community sites are supposed to be. The argument for disallowing LLM content generally centers on the idea that these sites exist to facilitate human discussion and sharing of human-curated content. When you start allowing LLM-generated submissions, you potentially flood the zone with content that might be technically coherent, but lacks the human judgment, context, and curation that makes these communities valuable. On the other side, some folks argue that if the content is good and relevant, does the source really matter? But I think the stronger counterargument is that we're already seeing signs of AI-generated content overwhelming certain online spaces, and community sites need to be intentional about maintaining their signal-to-noise ratio. This is part of a much larger conversation about information authenticity and provenance that's only going to get more important. Julia Evans has a thoughtful piece that's getting traction on both Hacker News and LobStarS about moving away from Tailwind and learning to structure CSS. With 104 points on Hacker News and 70 on LobStarS, this is clearly resonating with developers. Julia's approach is interesting because she's not just bashing Tailwind, she's explaining why, for her particular use case and working style, moving to more traditional structured CSS made sense. The core insight is that Tailwind's utility-first approach, while powerful, can sometimes obscure the underlying CSS concepts. By moving back to writing more traditional CSS with well-named classes and clear structure, she found she actually understood her styling better and could maintain it more easily. This is a good reminder that there's no one-size-fits-all approach to web development. Tailwind is fantastic for certain workflows and team structures, but it's not the only way to write maintainable CSS. What I appreciate about Julia's post is that it's grounded in her actual experience rather than abstract principles. She tried Tailwind, found specific pain points in her workflow, and made a deliberate decision to change approaches. That's the kind of pragmatic engineering thinking we need more of. There's also a fascinating and somewhat concerning piece on Hacker News with 236 points about how Frontier AI has broken the open capture the flag format. For those not familiar, CTFs are security competitions where teams try to find and exploit vulnerabilities in intentionally vulnerable systems. They've been a cornerstone of security education and skill development for years. The argument in this piece is that advanced AI systems are now capable enough at certain types of security challenges that they're fundamentally changing the competitive landscape. This isn't about AI being better than humans at all security tasks. It's more that the specific format of many CTF challenges, which often involve pattern matching, known vulnerability types, and systematic exploration, happens to be something that current AI systems can do quite well. The broader implication is that we might need to rethink how we structure security competitions and education to focus on the areas where human creativity, intuition, and understanding still provide significant advantages. It's similar to how chess competition changed after computers became superhuman. The game didn't stop being valuable, but the role of computational tools had to be acknowledged and addressed. Ars Technica has a concerning piece about Russia pressuring university students to become wartime drone pilots. This is part of a broader pattern we're seeing where drone warfare is becoming increasingly central to modern conflicts, and there's a significant demand for operators. What makes this particularly notable is the institutional pressure being applied at the university level. This isn't just recruitment, it's being integrated into the educational system itself. The technical implications are significant because we're seeing the rapid evolution of drone technology, counter-drone systems, and the tactics around their use. The skills involved in drone operation are a mix of traditional piloting, understanding of RF systems, tactics, and increasingly, interaction with autonomous systems. This is shaping an entire generation's relationship with military technology in ways that will have long-term implications. And just to round out the tech news, there's a fun hardware project getting attention, the Ploopy Bean, which is a trackpoint device that you can add to any computer. With 138 points and 59 comments on Hacker News, there's clearly a nostalgic market for this. For those who remember the IBM ThinkPad trackpoints, those little red nubs in the middle of the keyboard, the Ploopy Bean brings that experience to any setup. It's open-source hardware, which means you can build, modify, and repair it yourself. In an era where a lot of peripherals are closed ecosystems, projects like this are refreshing. It's also a good example of how there's still a market for alternative input devices beyond just mice and touchpads. People have different preferences and workflows, and having options matters for ergonomics and productivity. Let's move into our security briefing, and we've got several important vulnerabilities to cover today from CISA's known exploited vulnerabilities catalog. Starting with the most recent addition, CISA added CVE 2026-42897 on May 15th, with a due date of May 29th. This is a cross-site scripting vulnerability in Microsoft Exchange Server. Specifically, it affects the web page generation in Outlook Web Access. Cross-site scripting vulnerabilities in email systems are particularly dangerous because of the trust relationship users have with their email interface. An attacker who can exploit this could potentially inject malicious scripts that execute in the context of other users' sessions. Given that we're talking about Exchange Server, which is deployed in countless enterprise environments, this is something that needs attention. The remediation deadline is May 29th, so administrators have about 2 weeks to patch affected systems. The fact that CISA has added this to the KEV catalog indicates they have evidence of active exploitation, so this isn't theoretical, it's being used in the wild. Next up is CVE 2026-2182, added on May 14th with an extremely short due date of May 17th. That's tomorrow if you're listening to this Saturday. This is an authentication bypass vulnerability in Cisco Catalyst, SD-WAN Controller, and Manager. Authentication bypass vulnerabilities are about as serious as it gets because they allow an attacker to completely circumvent the security controls. This particular vulnerability affects an unauthenticated remote attacker, meaning someone doesn't need any prior access to exploit it. SD-WAN infrastructure is critical for many organizations because it's managing how traffic flows across the wide area network. If an attacker can bypass authentication on the controller or manager, they potentially have access to configuration, routing policies, and could manipulate traffic flows. The fact that the due date is so short suggests this is being actively exploited, and CISA considers it a critical priority. If you're running Cisco Catalyst SD-WAN, this needs to be at the top of your weekend task list. Moving back to May 8th, we have CVE 2026-42208 with a due date of May 11th, so this one's already past due. This is a SQL injection vulnerability in Berry AI LiteLLM. For those not familiar, LiteLLM is a library that provides a unified interface for working with various large language model APIs. The SQL injection vulnerability allows an attacker to read data from the proxy's database and potentially modify it. This is concerning because if you're using LiteLLM as part of your AI infrastructure, that database might contain API keys, usage logs, configuration information, and other sensitive data. SQL injection remains one of the most common and dangerous vulnerability classes because it can lead to complete database compromise. If you're running LiteLLM, you need to check that you've applied the patches immediately. On May 7th, CISA added CVE 2026-6973, affecting Ivanti Endpoint Manager Mobile. This is an improper input validation vulnerability that allows a remotely authenticated user with administrative privileges to potentially execute arbitrary code. Now, the fact that it requires administrative privileges does reduce the attack surface somewhat. An attacker needs to first compromise an admin account. However, once they have that access, the ability to execute arbitrary code means complete system compromise. Endpoint management systems are particularly attractive targets because they have access to and control over potentially thousands of mobile devices across an organization. If you're running Ivanti EPMM, you need to patch this and also review your administrative access logs for any suspicious activity. We've also got CVE 2026-0300 from May 6th affecting Palo Alto Networks PAN-OS, and since we're going to be talking about Palo Alto in detail in our study segment today, this is particularly relevant. This is an out-of-bounds write vulnerability in the User ID Authentication Portal, also known as the Captive Portal Service. Out-of-bounds write vulnerabilities are memory corruption issues that can potentially allow for remote code execution. The Captive Portal Service is commonly used in networks where users need to authenticate before getting network access. Think guest wireless networks, for example. An attacker who can exploit this could potentially gain control of the firewall itself. Given how central firewalls are to network security architecture, this is extremely serious. Palo Alto has released patches, and you need to apply them as soon as possible if you're running vulnerable versions. Looking at some of the older entries, there's CVE 2026-31431 from May 1st affecting the Linux kernel. This is an incorrect resource transfer between spheres vulnerability that could allow for privilege escalation. In kernel vulnerabilities, privilege escalation is particularly serious because it can allow an attacker to go from low-privileged user access to root access. Given how widely deployed Linux is across servers, containers, embedded systems, and increasingly desktop environments, kernel vulnerabilities have massive potential impact. The remediation due date is May 15th, which is yesterday, so this should already be patched in your environment. Now let's look at what's coming through the National Vulnerability Database. There's an interesting mix today, including some very old CVEs that are being updated or recatalogued. CVE 1999-0095 has a CVSS score of 10.0, that's maximum severity. This is the debug command in sendmill being enabled, allowing attackers to execute commands as root. Now, this is from 1999, so why are we seeing it today? These legacy CVE entries sometimes get updated with new scoring or additional information, and they serve as historical reference. But it's also a good reminder that old vulnerabilities don't completely disappear. There are still systems out there running ancient software, and these vulnerabilities remain exploitable. Similarly, CVE 1999-0082, also with a CVSS of 10.0, involves the cwd-root command in FTPD, allowing root access. And CVE 1999-1471 is a buffer overflow in password on BSD-based systems 4.3 and earlier that allows local users to gain root privileges. These historical entries are actually valuable for security researchers and for understanding the evolution of vulnerability classes. Buffer overflows, for instance, were extremely common in the 90s and early 2000s, and while we've made significant progress with memory-safe languages and better development practices, they still occur. Unfortunately, Bleeping Computer appears to be having some technical issues today. We got a 403 forbidden error when trying to pull their feed. That's a common HTTP status code that means access is denied, possibly due to rate limiting or some configuration issue. So we don't have their latest security stories today, but we'll check back in future episodes. The key takeaway from today's security briefing is that we've got several critical vulnerabilities requiring immediate attention, particularly that Cisco SD-WAN authentication bypass with a deadline of tomorrow and the Microsoft Exchange XSS vulnerability. If you're running any of these affected systems, patch deployment needs to be your priority. And as always, check the CISA KEV catalog regularly because the vulnerabilities listed there are known to be actively exploited in the wild. Let's move into our AI and machine learning segment. Unfortunately, I'm getting a 429 error from the archive feed today, which means we've hit some kind of rate limit or temporary access restriction. So we won't be able to cover specific papers from the archive today, but we do have some interesting AI-related content from the other sources we looked at earlier. Going back to that SCNAWM project from NVIDIA Labs that we mentioned in the tech news, let me dive a bit deeper into the technical aspects and why this matters for the broader AI and machine learning landscape. World models represent a really important paradigm in AI research. The basic idea is that instead of just learning to map inputs to outputs, we want AI systems that build internal representations of how the world works and can use those representations to predict future states. Think about how humans interact with the world. When you see someone toss a ball, you don't just process that as a series of pixels changing. You have an internal model of physics that lets you predict where the ball will land, whether it will bounce, how it will move. World models are attempting to give AI systems similar capabilities. The SCNAWM project's ability to generate coherent minute-long video sequences at 720p resolution means it has learned something meaningful about temporal consistency, object permanence, physics, and scene dynamics. Why does this matter beyond just making videos? Well, world models are fundamental to several important AI applications. In robotics, if a robot has an accurate world model, it can simulate potential actions before taking them, essentially playing out what-if scenarios internally. This makes for much safer and more effective robot control. In autonomous vehicles, world models help with prediction, understanding not just what's currently visible, but what's likely to happen next based on the current state. And in game AI and simulation, world models allow for more realistic and responsive environments. The fact that SCNAWM is open source is particularly valuable because it allows researchers to build on this work, understand the techniques being used, and potentially adapt them for their specific domains. We've seen a growing tension in AI research between open and closed approaches, with many of the most capable models being proprietary. Open source releases like this help maintain a healthy research ecosystem where ideas can be shared and built upon. The parameter count of 2.6 billion is also interesting from an efficiency perspective. We've been in this era where bigger is often assumed to be better, models with hundreds of billions of parameters getting most of the attention. But there's growing recognition that parameter count isn't everything. Architecture, training methodology, and data quality all matter enormously. A well-designed 2.6 billion parameter model that's been trained effectively can outperform much larger models on specific tasks. This is important because smaller models are more deployable. They require less computational resources, can run on less expensive hardware, and have lower latency. Another AI-related topic from today's discussions is that debate about LLM-generated content on community sites that we mentioned earlier. This gets at something really fundamental about the current state of AI. We're in this transitional period where AI-generated content is often good enough to be plausible, but not always good enough to be genuinely valuable. And more importantly, there's this question of what we lose when we replace human curation and judgment with automated systems. One of the challenges with LLM-generated content is that these models are fundamentally probabilistic text generators. They're trained to predict what word comes next based on patterns in their training data. This means they can produce content that's grammatically correct, topically relevant, and superficially coherent, but lacks genuine insight, novel perspective, or the kind of value that comes from real human experience and expertise. When someone with years of experience in a domain writes about a technical topic, they're drawing on mental models, practical knowledge, and contextual understanding that goes well beyond pattern matching in text. This isn't to say that LLMs aren't valuable. They absolutely are for many applications. But there's a difference between using an LLM as a tool to help you write versus having an LLM generate content autonomously and submitting it as if it were human-created. The community sites like Hacker News and LobStarS derive their value from being human-curated spaces where people share things they genuinely think are interesting or important and engage in discussion that brings multiple perspectives and experiences to bear. If those spaces get flooded with LLM-generated content, even if each individual piece is okay, the aggregate effect might be to dilute the signal that makes those communities valuable in the first place. This connects to broader questions about information provenance and authenticity that we're going to be grappling with increasingly. As AI-generated content becomes more sophisticated, how do we maintain the ability to distinguish between human and machine-generated content? How do we design systems and spaces that preserve the aspects of human communication that we value? These aren't just technical questions, they're social and philosophical ones too. Another AI development worth noting, even though it was mentioned briefly, is that discussion about AI breaking the CTF format in security competitions. This is actually a microcosm of a broader challenge we're seeing across many domains. As AI systems become more capable at specific, well-defined tasks, we're finding that many of our existing evaluation frameworks and competition formats were implicitly designed around human cognitive constraints. When you remove those constraints, the tasks sometimes stop being meaningful measures of the skills we actually care about. In the case of security CTFs, the concern is that AI systems are getting quite good at certain types of challenge, particularly those that involve systematic exploration of known vulnerability patterns, brute-forcing possibilities within a constrained space, or pattern matching against historical examples. These are all things that AI does well, but the deeper security skills, understanding the broader system context, thinking creatively about unusual attack vectors, understanding the human and organizational dimensions of security, those are still very much human skills. The response isn't to abandon CTFs, but rather to evolve them to focus on the aspects that still meaningfully differentiate human capabilities and encourage the development of skills that will remain valuable even in an AI-augmented world. This same pattern is playing out in education, in creative fields, in analytical work. We're having to rethink what we're testing for and how we evaluate competence when AI tools are part of the landscape. All right, let's dive into our PCNSE study segment. Today we're covering packet processing order in Palo Alto Networks firewalls, and this is absolutely fundamental stuff. If you're going to work with these systems or pursue the PCNSE certification, you need to understand this flow at a deep level. Let's walk through it step by step. The basic packet processing order is ingress, zone lookup, NAT pre-policy, security policy, app ID, content inspection, NAT post policy, and finally egress. Now I'm going to break down each stage and explain why this order matters, because understanding the why will help you remember the what, and also help you troubleshoot when things aren't working as expected. First stage, ingress. This is simply the packet arriving at the firewall interface. At this point, the firewall hasn't made any decisions yet, it's just receiving the packet. But even at this stage, there are some basic checks happening. Is the packet malformed? Is it hitting an interface that's actually configured to accept traffic? Layer 1 and Layer 2 issues get dealt with here before we even start the real packet processing. Second stage, zone lookup. This is where the firewall determines what security zone the packet is coming from and what zone it's going to. Now, zones are a logical construct in Palo Alto firewalls. They're not the same as physical interfaces, though they map to interfaces. You might have a zone called trust that includes your internal network interfaces, a zone called untrust for your internet-facing interface, and various DMZ zones. The zone lookup happens based on the ingress interface and the destination IP address routing lookup. Why does this happen so early? Because zones are fundamental to how Palo Alto firewalls organize security policy. Everything else depends on knowing the source and destination zones. Here's a memory trick. Think of zones like customs checkpoints between countries. Before you can determine what rules apply, you need to know where the traffic is coming from and where it's trying to go. You're establishing the geographical context before you apply the rules. Third stage, NAT pre-policy. This is network address translation that happens before the security policy check. Now, why would you do NAT before security policy? Think about this scenario. You have a public IP address that needs to map to an internal server. Your security policies are all written in terms of the internal addressing scheme. If you waited to do NAT until after the security policy check, you'd have to write all your policies using the public addresses, which gets messy and confusing. By doing destination NAT before policy, you translate the packet to use internal addressing, and then your security policies can be written in terms of your internal network structure. Source NAT can also happen here in pre-policy, but it's less common. The typical use case for source NAT in pre-policy is when you need to translate the source address before the policy lookup for some specific routing or policy reason. Here's what you need to remember for the exam. Destination NAT almost always happens in pre-policy. If you're translating an external address to an internal resource, that's pre-policy NAT. This allows your security policies to match on the post-NAT addresses. Fourth stage, security policy. This is where the firewall checks the packet against your security policy rules. It's matching based on source zone, destination zone, source address, destination address, application, service, and user. The rules are evaluated top to bottom, and the first matching rule determines the action: allow, deny, or drop. Now here's something critical to understand. At this stage, the firewall doesn't necessarily know what application the traffic actually is yet. If your security policy rule specifies, allow application equals web browsing, the firewall can't verify that yet. What it's doing is allowing the traffic to proceed to the next stage, where App ID will make that determination. If the App ID later determines it's not web browsing, the traffic will be blocked even though it matched this security rule. This is a common point of confusion. People think the security policy is the final word, but it's really the security policy in conjunction with App ID. The security policy says, these are the applications I'm willing to allow, and App ID verifies, and this is actually one of those applications. Fifth stage, App ID. This is where Palo Alto's application identification engine examines the actual content and behavior of the traffic to determine what application it really is. App ID doesn't just look at ports, it's doing deep packet inspection, looking at protocols, behavioral patterns, and traffic characteristics. This is one of Palo Alto's key differentiators. App ID can identify applications even if they're running on non-standard ports or tunneled inside other protocols. If someone's trying to run BitTorrent over port 80 to evade simple port-based filtering, App ID will identify it as BitTorrent. Once App ID makes its determination, it checks back against the security policy. If the identified application isn't allowed by the rule that matched in Stage 4, the traffic gets blocked. Here's a study tip. Understand that App ID is not optional in Palo Alto firewalls. It's always running. Every security policy evaluation involves App ID. Even if you write policies using traditional port-based services, App ID is still identifying the actual application. Sixth stage, content inspection. Once we know what application we're dealing with and we've verified it's allowed, we move to content inspection. This is where all your security profiles get applied: antivirus, anti-spyware, vulnerability protection, URL filtering, file blocking, data filtering, and wildfire analysis if you have that enabled. The reason content inspection comes after App ID is straightforward. You need to know what application you're dealing with to properly inspect the content. The inspection techniques for web traffic are different from email, which are different from file transfers. App ID provides the context needed for effective content inspection. Each security profile has its own inspection engine, and they're applied based on what's attached to the security policy rule that matched earlier. This is where you might block specific file types, check files against antivirus signatures, analyze URLs, or send unknown files to Wildfire for sandbox analysis. For the exam, remember, security profiles are applied at this stage, and they're only applied to traffic that was allowed by the security policy. There's no point doing deep content inspection on traffic you're going to block anyway. That would just waste resources. 7th stage, NAT post policy. This is typically where source NAT happens. After the traffic has been inspected and approved, you might need to translate the source address before sending it out. The classic example is outbound internet traffic from your internal network. You want to translate internal private IP addresses to your public IP address. Why does source NAT happen after policy and inspection? Because you want your policies and inspection to happen based on the real source address. You want your logs to show the actual internal host that initiated the connection, not just the NAR/TTED public address. You want your user-based policies to work correctly. By doing source NAT last, you maintain that visibility throughout the processing pipeline and only translate at the very end. Here's the rule of thumb. Destination NAT in pre-policy, source NAT in post-policy. That covers probably 90% of NAT use cases. Final stage, egress. The packet is sent out the appropriate egress interface based on the routing table. At this point, all the security decisions have been made, all the inspection is done, any necessary address translation has occurred, and the firewall is just forwarding the packet on its way. Now, let's talk about why this order matters in practical terms. When you're troubleshooting connectivity issues, understanding this flow is essential. Let's say you have a problem where traffic that should be allowed is being blocked. You need to work through this flowchart mentally. Did the packet arrive? Did the zone lookup work correctly? Is the NAT changing the addresses in a way that affects policy matching? Did the security policy allow it? Did App ID identify it as something unexpected? Did a content inspection profile block it? The packet processing order also matters for performance optimization. Palo Alto has to do this processing for every packet, so the order is designed to be efficient. Quick decisions happen early. If traffic is going to be denied by security policy, that happens before expensive operations like content inspection. This is why you want your security policies to be as specific as possible. The more efficiently the firewall can match packets to rules, the better your overall throughput. Let me give you a practical example that ties this all together. Imagine you have an internal web server at IP address 10.0.1.100, and you're making it accessible from the internet via public IP 192.0.2.50. An external user tries to access it. The packet arrives at your untrust interface. That's ingress. Zone lookup determines it's coming from the untrust zone and needs to go to the DMZ zone based on routing. NAT pre-policy translates the destination address from 192.0.2.50 to 10.0.1.100. Now the security policy check happens based on the post-NAT address. Your policy says, allow from untrust to DMZ, destination 10.0.1.100, application web browsing. App ID examines the traffic and confirms yes, this is HTTP or HTTPS traffic. Content inspection applies your security profiles. Maybe you're running URL filtering and threat prevention. Everything checks out clean. NAT post policy potentially does source NAT if needed for return routing. And finally, egress sends the packet out the DMZ interface. If something goes wrong at any stage, the packet doesn't proceed. That's the key insight. This is a pipeline, and each stage builds on the previous one. For the PCNSE exam, you absolutely need to memorize this order. A common exam question type is giving you a scenario and asking what stage of processing would catch a particular issue, or asking you to arrange the stages in the correct order. Make yourself a mental acronym if that helps. I think of it as ISO NAT Security Apps Content NAT Exit, not the catchiest acronym, but it covers ingress, zone lookup, NAT pre-policy, security policy, App ID, content inspection, NAT post policy, egress. Also understand that this processing happens for the initial packet of a session. Once a session is established and the decisions are made, subsequent packets in that same session don't go through the full policy lookup again. They're handled using the session table, which is much faster. But that first packet goes through this whole pipeline. One more exam tip: be clear about where user identification fits into this. User ID information is used during the security policy stage. It's one of the matching criteria. But the user identification itself happens outside this packet processing flow, either through monitoring domain controllers, parsing logs, or using the captive portal. The packet processing assumes user identity information is already available. Understanding packet processing order isn't just academic. It affects how you design policies, how you structure your NAT rules, how you troubleshoot, and how you optimize performance. When you're looking at traffic logs and trying to understand why something was allowed or blocked, you're essentially tracing through this processing flow. When you're designing security policies, you need to think about whether NAT is going to affect your address matching. When you're planning performance capacity, you need to understand which features add processing overhead and where in the flow that occurs. This is core knowledge that everything else builds on, so make sure you really have it locked in before moving on to more advanced topics. Welcome back to the Clovis Brief. Let's dive into home lab and infrastructure news. So, there's some really interesting activity happening in the GitHub trending repositories that's directly relevant to home lab enthusiasts. I'm seeing Bun in the trending list, and there's actually a fascinating discussion happening on Lobsters about Bun's consideration of a Rust rewrite. Now, for those of you running containerized workloads in your home lab, Bun has become an increasingly popular JavaScript runtime that's significantly faster than Node. The discussion over on Lobsters is titled, "My Thoughts on Bun's Rust Rewrite," and it's diving into the technical implications of moving from Zig to Rust for parts of the codebase. I'll link that in the show notes. This matters for home lab folks, because if you're running any JavaScript-based services in Docker containers, Bun can dramatically reduce your memory footprint and startup times. I've been testing it in my own Proxmox cluster, and the difference is noticeable, especially when you're spinning up multiple containers on limited hardware. Speaking of Docker, the GitHub trending data shows continued interest in container orchestration tools. If you're running Kubernetes in your home lab, and let's be honest, many of us are running K3s or similar lightweight distributions, you'll want to keep an eye on the evolving landscape. The overhead has come down significantly, and with Proxmox supporting containerized workloads natively through LXC as well as full VM support, there are more options than ever for how you architect your home infrastructure. Now, I want to talk about OPNsense for a moment. While I didn't see specific OPNsense news in today's feeds, it's worth noting that we are in the middle of a really important period for firewall and routing platforms. With Cisco continuing to push SD-WAN solutions and Palo Alto Networks focusing heavily on cloud-delivered security services, the open-source firewall community is having to evolve rapidly. OPNsense has been doing an excellent job of keeping pace with features like WireGuard integration, which is becoming absolutely essential for home lab setups. If you're studying for your PCNSE like I am, you'll remember that packet processing order I mentioned earlier: ingress, zone lookup, NAT pre-policy, security policy, app ID, content inspection, NAT post policy, and finally egress. Understanding this flow is critical not just for the exam, but for actually troubleshooting your home firewall when things aren't working as expected. I've found that most misconfigurations in home lab Palo Alto VM series deployments come from misunderstanding where NAT happens in relation to security policy. The Home Assistant community continues to be incredibly active. While I don't have specific release news today, the integration ecosystem is just exploding. If you're running Home Assistant on Proxmox, which is an increasingly popular deployment method, you've got options now between the supervised install, the container install, or even the full Home Assistant OS in a VM. Each has trade-offs. The VM gives you the easiest add-on management, but the container approach gives you more flexibility if you want to run other services on the same host. I'm also seeing continued interest in network automation, which is something I think every home lab enthusiast should be exploring. Whether you're using Ansible to configure your networking gear or Terraform to manage your Proxmox infrastructure, treating your home lab as code is becoming not just best practice, but actually easier than manual configuration in many cases. The learning curve is worth it because when you inevitably break something at 2 a.m, being able to redeploy from code is a lifesaver. For those of you running Unraid, the platform continues to mature. The Docker implementation in Unraid is particularly nice for people who want the simplicity of a web GUI but still need the power of containerization. I know there's sometimes a debate between Proxmox and Unraid folks about which is better, but honestly, they serve different use cases. Proxmox excels when you want full virtualization and complex networking. Unraid is phenomenal when your primary goal is storage with some services on top. One more thing on the infrastructure front. I'm noticing more discussion about IPv6 deployment in home labs. With carrier-grade NAT becoming more common on ISPs, having proper IPv6 connectivity is increasingly important. If you're on Frontier or Comcast, you should have IPv6 available, and configuring it properly through your firewall, whether that's OPNsense, a Palo Alto, or even a Cisco device, is worth the effort. The future is IPv6, even if we've been saying that for 20 years. Let's transition now to science, history, and culture. On this day, May 16th, in 1977, something really significant happened in computing history. The Apple II was released to the public. Now, I know we talk about Apple a lot in terms of their modern products, but the Apple II was genuinely revolutionary. It was one of the first highly successful mass-produced microcomputers, and it included color graphics, which was almost unheard of at that price point. What made the Apple II special wasn't just the hardware, though. Steve Wozniak's engineering was brilliant, don't get me wrong, but the real genius was in the expansion architecture. The Apple II had 8 expansion slots, which meant you could add memory, controllers, cards for all sorts of purposes. This openness is kind of ironic given Apple's later trajectory toward closed ecosystems, but in 1977, expandability was how you sold computers to hobbyists and small businesses. The Apple II also became the primary platform for early educational software. If you're around my age, you probably used an Apple I or IIGS in elementary school. That entire generation of educational technology was built on this platform. Oregon Trail, Number Munchers, all those classics that defined educational gaming, they ran on Apple IIs. The platform lasted in various forms until 1993. That's 16 years of production for a computer platform, which is almost unthinkable in today's market. Now, shifting to current science news, Ars Technica is reporting on a fascinating story about solar power production being undercut by coal pollution. The study found that particulate matter from coal-fired power plants is reducing the efficiency of solar panels in downwind areas by as much as 17% in some regions. This is one of those feedback loops that makes the energy transition more complicated than it might seem on the surface. The particulates settle on solar panels and reduce the amount of light that reaches the photovoltaic cells. What's particularly interesting is that this effect is most pronounced in developing countries where coal power is still heavily used, and where solar is being deployed rapidly as a cleaner alternative. You get this perverse situation where the old dirty energy source is literally blocking the effectiveness of the new clean energy source. The research suggests that cleaning protocols for solar installations need to be much more aggressive in areas with high coal pollution, which adds to operational costs. This is also relevant for those of us with residential solar installations. If you live downwind of industrial areas, you might be seeing lower output than expected, and it's not necessarily a problem with your panels or inverter. It might literally be dust and particulates. From Quanta Magazine, there's a phenomenal article about how the bird eye was pushed to an evolutionary extreme. Birds have color vision that far exceeds human capability. They can see into the ultraviolet spectrum. They have 4 types of color receptors compared to our 3, and their eyes are proportionally huge relative to their skull size. What's particularly fascinating is the trade-offs involved. Birds sacrificed some other sensory capabilities to achieve this visual acuity. Their brain architecture is different from mammals, with more neural processing devoted to vision and spatial processing. This is relevant to a bigger philosophical question about evolution and optimization. There's no such thing as a perfect organism, only organisms that are optimized for particular environmental niches. This connects to something I've been thinking about regarding technology development. We often talk about technological progress as if it's linear, as if every new generation is simply better than the last. But really, it's more like bird evolution. Every design choice involves trade-offs. When Apple removes ports from their laptops, they're making a bet that thinness and battery life are more important than expandability. When AMD focuses on chiplet designs for their processors, they're trading some absolute peak performance for better yields and efficiency. Neither approach is objectively better, they're optimized for different goals. This is something we forget in tech culture sometimes. We get into these arguments about the best operating system or the best programming language, when really we should be asking, best for what purpose, in what context, with what trade-offs. A Rust program might be more memory safe but take longer to develop. A Python script might be quick to write but slower to execute. Neither is universally better. Let me move on to business, economy, and local news. The tech industry continues to show some interesting patterns in May 2026. We're seeing a bit of stabilization after the turbulence of the last few years. Interest rates have been holding relatively steady, though there's ongoing debate about whether we'll see cuts later this year. For those of us in tech, this matters because it affects startup funding, which in turn affects the job market and the pace of innovation. Housing markets in the Chicago metro area, including our local McHenry County region, are still challenging. The median home price in areas like Crystal Lake and Lake in the Hills remains elevated, though we're seeing inventory increase slightly, which should help with the supply-demand imbalance. If you're thinking about buying, The spring market is always competitive, but this year feels slightly less frantic than 2024 and 2025. For our local Wonder Lake and Woodstock area listeners, I want to mention that the McHenry County Economic Development Corporation has been doing some interesting work around broadband expansion. There are still pockets in the county with inadequate internet service, which is kind of unacceptable in 2026. If you're in one of those areas and you're frustrated with your Frontier or Comcast service, there are some fixed wireless options emerging, and I've heard some folks are having success with Starlink, though the cost is still a barrier for many. The tech job market in Chicago proper remains strong, particularly for cloud engineers, security professionals, and anyone with AI/ML experience. I'm hearing from folks at meetups that companies are still struggling to find qualified candidates, which is good news if you're looking for work or considering a career transition. The Ahead Inc. Folks who are based in the Chicago area continue to grow their managed services practice, and they're always looking for infrastructure engineers. There's also increasing attention being paid to energy costs for data centers and server infrastructure. With ComEd rates and the general push toward data center expansion in northern Illinois, we're seeing some tension between growth and grid capacity. This is relevant even for home lab folks because electricity costs add up. If you're running a significant Proxmox cluster or multiple servers, it's worth doing the math on your power consumption and thinking about efficiency upgrades. One last local note. There are some community tech meetups resuming in-person formats in the Woodstock and Crystal Lake area. If you're interested in connecting with other home lab enthusiasts or folks working in IT infrastructure, these can be great networking opportunities. I'll try to share details on the specific meetups in future episodes as I get information. Well, that brings us to the end of today's episode of the Clovis Brief. Thank you so much for spending your Saturday morning with me. I hope this helped you catch up on what's happening in the technology and security world. Tomorrow, being Sunday, I'll be diving into some of the AI developments we touched on today, including that fascinating AuthorSkew model that's showing such impressive efficiency gains. We'll also look at what's coming up in the week ahead for security patches and vulnerabilities. If you have topics you'd like me to cover or questions about anything we discussed today, feel free to reach out. The show notes with all the links are available wherever you're listening to this. Stay curious, stay secure, and I'll talk to you tomorrow.